In modern portfolio theory, investments are evaluated using expected return as a measure of reward and variance of return as a measure of risk. Let's talk about how to calculate the portfolio expected return and variance.
A portfolio's expected return is calculated like the expected value for a random variable. It's the weighted average of the expected returns for individual securities. The weights are based on the amount invested for each security. Before we can define the variance of return, we need to define the covariance of returns. The covariance between the returns of two assets, R sub I and R sub j, is calculated like this. It's the product of each random variable's deviation from its own expected value. This is a measure of how much the returns tend to move up and down together. The variance of a two-asset portfolio is calculated like this. Notice there are three terms. The first two terms incorporate the variances of the two assets, and the last term accounts for the covariance. We can write the covariance as the correlation times the two standard deviations. This means the correlation equals the covariance divided by the product of the two standard deviations. The correlation will always be between -1 and +1. It's a measure of the linear relationship between the two variables. So it's not a measure of any relationship between the variables, only the linear relationship. A correlation of 0 means no linear relationship. For a portfolio with three assets, the variance formula expands to this. You end up with many more terms because you have to consider the covariance between each pair of asset returns. That's why it's not feasible to calculate the variance of a portfolio with many securities without the aid of a computer. Mean variance analysis typically assumes returns are approximately normally distributed. Systematic risk, or market risk, is captured by the standard deviation of returns, but alternative approaches focus on only the downside risk. One example is the safety-first ratio. This measures the shortfall risk, which is the risk of the portfolio value will fall below some threshold level. The safety-first ratio is calculated like this: the expected portfolio return minus the threshold level divided by the standard deviation. This scales the difference between the expected return and the threshold level into standard deviations. The portfolio with the highest safety-first ratio should be chosen. That portfolio will have the lowest probability of falling below the threshold level. If the returns are normally distributed, the probability of the return falling below the threshold level can be calculated like this. It's the cumulative normal distribution value of the opposite of the safety-first ratio. We need to look up the value for n of negative SF ratio in a normal distribution table.
That wraps up the summary on portfolio mathematics. This is a short video, but that doesn't make it any less important, so make sure you understand these topics.